Okay, today we're looking at our notes for calculating and interpreting correlation coefficient. So, what is correlation coefficient? When we do a regression, it's what's called our R value. So, whenever we do a regression, we'll see R squared. We want to pay attention to R. The value will be between -1 and +1. It measures the strength and direction of the association or the correlation of the two variables calculated by using the linear regression. So basically, what we're looking at is when we look at this, okay, I want to start right here over on this side. This is R equals 1. And if you look, this makes a solid line that goes like this. That means that they're all in a line, okay, and their slope would be 1, okay. So with the R value being 1, that means they are perfectly in line with each other. And with R being -1, that means they're also in a line. The only difference is that the slope is going down. So there is a positive negative part to this, which is just saying which way the direction is. But the strength depends on how the dots are laid out. So an R value of 1 or -1 means that they're perfectly in line. A value where it's 0.5 or -0.5, you notice if I draw a straight line that goes through that, I don't hit all of the points. I hit some of them, but I'm in between some others. That's because this, my correlation has gotten weaker from here to here, and it's not as tied tightly. And then here, when my correlation coefficient is 0, that means it's incredibly weak, almost to the point where there is no correlation or no association. So I'm going to go ahead and say no association, meaning the data is not supporting any sort of association between these two things. A closer the value of R is to either 1 or -1, the stronger the linear association. The closer the value of R is to 0, the weaker the linear association. So if you're looking at this right here, we would look at this value right here, this R value, and this is -0.0393. Excuse me. You see this part where it says moderate? Cross that out. Anywhere you see moderate, just go ahead and cross it out. We're not going to test you on moderate. We're only going to test you on strong or weak. Okay? So zero point 0.9, 0.9, 0.093 negative. That is very strong because that is very close to -1. Okay? Much further away than 0. That's what you're trying to see. You're looking at a line right here. We have 0 right here. We have -1 right here. 0.93 would be right over here. So that's a very strong R value. On the next one, my R value is 0.996. So again, I have 0, I have 1 over here, I have 0.96. Okay? 0.96. Again, that's very strong because it's close to 1. If I was to graph this one, here's 0, here's -1, here's +1. This is 0.20. So that would be right here. That'll be less than a quarter of the way, zero point 0.2. Okay. So that I would actually say is weak because it's close to 0. Now, the other part of correlation isn't just how strong the data set is, it's also its direction. The association or correlation, the type of relationship between the two data sets, there are 3 association correlations. There's this one, which is going down, that's negative. Okay. Here, that's a positive correlation. And again, here, just like over here, when we have the straight line going across, when we have the straight line going across here, it's again no association. So when I go down to this data set right here, This is a negative 0.93, so that's a negative correlation. This is a positive 0.96, that's a positive correlation. Ooh, I forgot to write my R value here. This is negative 0.2. And again, even though it's weak, my R is still negative, so that's a negative correlation. So they're both going in the negative direction. This one's going in the positive, this one's going in the negative. So one says how strong the correlation is, and the other one just says the direction. So here's a typical question you could have. You have this data set right here, okay? It says, what correlation best describes the strength and linear association between the weight and the value of these coins? So here's my question for you. Let's think about this for a second. They're associating that the weight of coins, of a set of coins, and their value. Well, we know, like, it doesn't make it. So the question is, the more coins by weight, should they value more? Should that be correlated with each other? So the way you do this is you have to type in all of the values. Yes, every single one of these values, the 1, 2, 3, 4, 5, 6, 7, 8, 8 points, and graph it. Now, unfortunately, on this video, you can't see my graph at all. But once you graph it, be sure to hit the little. By the way, I did it like this. This was my X value, and this was my Y value. And when after you type it in, make sure that you hit the little magnifying glass to see your line. And you'll notice right away that it has a positive correlation, which makes sense because the more coins you have, their value should increase. And these are random sets of coins. So yes, if you just had a bunch of pennies compared to like 2 quarters, yeah, I totally understand that that correlation is not going to be there. But that's not what they're saying here. They're not specifically picking out coins. It's just a random set. So because of that, yeah, it does appear that there's a positive correlation. And the R value I got was 0.927. It makes sense that it's not 1 because it's not a direct correlation, right? We know this because, again, you could have different coins, weigh different things, and their values are different, okay? But does appear that there is a strong positive correlation between the weight of coins and their value of these coins. So if someone gives you a sack of coins, it does appear that the heavier the sack, okay, the heavier the pouch of coins, the heavier or the more value they're going to be. So that's a strong positive correlation. All right, and that was your notes for calculating and interpreting the correlation coefficient.